This video goes over examples of the addition identities or compound angles. So these are identities that have previously been proven that you can use when simplifying expressions or solving equations. We've got sine x plus y is equal to sine x cos y plus cos x sine y. Then the cosine version of that is cos x cos y minus sine x sine y. And then finally the tan version, tan x plus tan y over 1 minus tan x tan y. The opposite of that are the subtraction formulas. So the sine version, we have sine x cos y minus cos x sine y. Cosine version is cos x cos y plus sine x sine y. And then the tan version, another fraction, tan x minus tan y, all over 1 plus tan x tan y. And so we can use these compound angle formulas to determine the exact trig ratios for angles that can be expressed as sums of different special angles. So the first thing we're going to do is just practice going from the compound angle version to the expanded version. So the first term inside my brackets, this is our x term. Second term, this is our y term, and we're using the sine version of our angle over here. So we've got sine and sine. And so when we expand that, we've got sine x, which is 2x in this case, times the cosine of 3y. And we're going to subtract, I'm going to write it down below just in the interest of space, cos x, which is 2x, and then sine y, which is 3y. Second identity that we're expanding is with cosine, which means that we're using this one up here, cos x plus y. So my first term, again, this is my x. My second term, this is my y. So when I expand this, I have cosine of 2a, which is my x, times the cosine of 3b. And then I'm going to take away the sine of x, which is 2a, times the sine of y, which is 3b. The last one is the tan version. So tan of 4x minus 5y. So that means that we're using this identity to expand. My a value is the first value here, or my x value. My b value is the second one. When I expand, I've got tan a minus tan of 5y all over 1 plus tan of x, which is 4x, times the tan of 5y. The second example here is taking things from their expanded form back into their compound angle formula. So here I'm looking to see which right-hand side of my identities does this go with. I see 2 cosines and 2 sines. So I'm either looking at cosine of x minus y or cosine of x plus y. Since this one has a subtraction sign in the middle, I know that I'm looking at this one right here, the cos x plus y. So my first one, my x, this is 2a is my x value, and 5a is my y value. So I can consolidate by saying that this is equal to cos of x plus y, which I can further simplify to 7a just by collecting like terms. So I'm going to do the same thing on the right-hand side. Use purple for this. So here I've got sine cos, cosine. So I know it's not one of the tan ratios. It looks like it's either my sine x minus y or my sine x plus y. Since it has a subtraction sign in the middle, I know that this is my sine x plus y formula, this one right here. And I can use that. This is my x term, and this one is my y term, and I can use that identity to consolidate into sine of x minus y, which finishes off as sine of 3a. The third example is tan. I have a subtraction symbol on the top. And so I can see that this is going to match up with my tan x minus y, where 4a is my x value, 3a is my y value. When I condense that to tan x minus y, this just simplifies to tan of a. The last one, I've got cos, cos, sine, sine. When I see that pattern, I'm looking at my cosine ratios. Let's use orange. Haven't used that color yet. So cos, cos with a plus in the middle. That is my identity of cosine x minus y. So that is the one that I'm matching up with here, where x plus 2 is my x value and y plus 3 is my y value. So when I consolidate that, I'm going to get cos of x, which is x plus 2, minus y plus 3, which I can simplify a little bit further to x minus y minus 1. The next thing that we're going to do is evaluate, and we're going to leave as exact answers. So that means that I'm going to need my special triangles. So I'm going to draw them out to start. I've got pi over 3, pi over 6, 1, root 3 and 2. And then I have my second one, pi over 4, 1, 1, and root 2. So I notice that I'm using cos of pi over 3 minus pi over 4. So that means that I'm using my cosine identity to simplify them. And that cosine identity is cosine of x, cosine of y, and then I'm going to add the sine of x times the sine of y. So I know that both of these angles are in the first quadrant, so they are going to end up being positive answers. And then I'm going to use my special triangles to figure out the value of the ratios. Cosine of pi over 3 is my adjacent over the hypotenuse. Cosine of pi over 4 is also adjacent over the hypotenuse. Sine of pi over 3 would be root 3 over 2. And then sine of pi over 4 is also 1 over root 2. So then I'm going to collect like terms. I notice that these have the same denominator, so I can simplify this to 1 plus 3 over 2 root 2. Let's do the second one, which is a sine ratio. So here I've got sine x minus y, so that is the identity that I'm using. This one is sine x cosine y minus cosine x times sine y. Okay, now I notice, so 5 pi over 6, my x value, that is going to be in my second quadrant. So I know that the sine of this is going to be positive, but the cosine of this is going to be negative. Pi over 2 is one of those special angles. Oh, I've got to put sine in there. And so I'm going to be using my cosine graph and my sine graph to figure out those values. This is pi over 2, and then this is pi over 2 here, or you can use the unit circle. So sine of 5 pi over 6, I go to my special triangle. This is 1 over 2 sine is positive in the second quadrant, so it is positive 1 over 2. Cos of pi over 2 is 0. Cosine of 5 pi over 6 is negative because it's in the second quadrant and is root 3 over 2. Sine of pi over 2 is 1. That's where sine is at a maximum. This term goes to 0, and then I'm going to have positive root 3 over 2. The last example, we're going to be using tan 4. So I've got my x value and my y value. Since I'm subtracting, that is the identity that I'm going to use. So I've got tan of x, which is 5 pi over 3. Take away tan of y, which is pi over 4, all over 1 minus those two values multiplied together. So I've got 5 pi over 3, and then tan of pi over 4. So tan is positive only in the third quadrant. 5 pi over 3 happens to be in the fourth quadrant. So that means these two ratios are both going to have negative values. Tan of pi over 4, that's in the first quadrant. So those ones are going to be positive. So tan of pi over 3 is opposite over adjacent minus tan of pi over 4, which is just 1. Then I'm going to have 1 minus tan of 5 pi over 3, which is the same value as above, minus root 3 over 1. This one should also be negative up here. And then I've got tan of pi over 4, which is 1. When I simplify that, on top, I'm going to have minus root 3 minus 1 over 1 plus root 3 to give me my exact value of tan 5 pi over 3 minus pi over 4.